So in these problems, we are going to look at doing compositions where our trig functions are two different types of trig functions. So for example, if I have the inverse sine of the tangent of minus pi over 4. So we're going to start by working on the inside function. So the inside function, we just want to find the tangent of minus pi over 4. So the tangent of minus pi over 4 turns out to be equal to -1. So we're looking at the inverse sine of -1. And so remember, I'm saying that's equal to some angle theta. And so what we're saying is that the sine, the sine of theta has to be equal to -1. And so if we think about when the sine of theta is equal to -1, that's going to happen here in terms of quadrants 1 or 4. And so we're going to be rotating this way, so that's rotating minus pi over 2 degrees. So theta is going to be minus pi over 2, and so the answer to this problem is going to be minus pi over 2. So we'll look at another one here. So the cosine of the inverse sine of root 3 over 2. So again, I want to start with the inside function. So the inside stuff here, we're going to let be theta. So we're saying that the sine of theta is equal to root 3 over 2. And so we have to look in quadrants 1 or 2. And so if we're looking at where the sine of theta is equal to root 3 over 2, that happens when theta is equal to pi over 3. So I figured out that the inside of this parenthesis here is pi over 3. So this whole problem is now becoming the cosine of pi over 3. And the cosine of pi over 3 is 1/2. So all we have to do is that. So on these ones where you have two different trig functions, you basically want to start on the inside, figure out what it is, and then go to the outside. So we'll do one more example, because a couple of these problems you might not be able to just do it right away. So for instance, if I have the cotangent of the inverse cosine of 4/5, so again, we're going to let this inside stuff be equal to theta. So we're talking about the cosine of theta is equal to 4/5. Now, 4/5 is not something you can look up on the unit circle. However, we can think about it in terms of a triangle. So if this is theta, then the cosine of theta equals 4/5 is telling us that so cosine is the adjacent 4 over the hypotenuse 5. So we can use Pythagorean theorem to find the other side. So 4 squared plus b squared equals 5 squared. So 16 plus b squared equals 25. So b squared equals 9. So b is going to be 3. So this side here is 3. And while I can't figure out exactly what the angle is, really now all I want to figure out is the cotangent of theta. And so remember, cotangent is the adjacent over the opposite, so it's going to be 4 over 3.